Welcome everybody to part 2 of our weathering notes. Again, hopefully you have the fill-in-the-blank notes, so these notes will be easier for you to take. And as always, when we get back to class, if you have any questions about the notes, if you are still wondering about some things that were mentioned in the videos, please ask. These are meant to be a pretty good introduction to weathering. Now, weathering rates. Weathering rates. When we talk about weathering rates, we need to talk about rock type, structure, and climate, because these things are primarily going to control the weathering rates. Rocks composed of minerals that are relatively unaffected by chemical weathering will be the most resistant to weathering. Now, as the temperatures range, if the temperatures typically, a lot of times this will happen at night, but if it can get so that the temperature is low enough where it freezes at night and during the day it's warm enough that it thaws, these are really good conditions for physical weathering, especially if you have a plentiful amount of water. Now, if you have warmer temperatures, even hotter temperatures, and a plentiful amount of water as well, this is good for chemical weathering. So you see with both physical and chemical weathering, water really is an essential part. So areas with little water or low temperatures tend to be relatively slow when it comes to chemical weathering. Now here's a question for you. What's going to weather faster? One 10-kilogram rock? So if you have one rock that has a mass of 10 kilograms, or if you compare it to 10 1-kilogram rocks, which one's going to weather faster? Now they're the same material, and they're also in the same environment. Which one do you think is going to weather faster? Now, if you said that 10 1-kilogram rocks, you're absolutely correct. And a lot of people say, well, why? Why is that? The other rock has a lot more mass. Why wouldn't it weather faster? Well, it all has to do with something called surface area. So if we look at this slide right here, I'm going to pull up a pen. Let's go with red again. So you can see this is your one 10-kilogram rock. So just pretend it's 10 kilograms. Now, how many sides does it have? If you said it has 6 sides, you're right. Now, you look at this rock right here. It's just basically a rock that's been broken into pieces. Now, normally rocks wouldn't break off into these perfect cubes. But if you look at the surface area, it now has 12 square units. So even though it's the same size, the surface area is doubled. And twice the surface area allows for it to be weathered that much faster. So let's get into soil. When we talk about soils, a lot of times people say, well, it's just dirt. And who needs soil anyway? Well, soil, without it, we would be naked, homeless, and starving. Plants, which rely on soil for survival, fill some of our most basic human needs. Shelter, clothing, whether made from natural or synthetic materials, are plant-based. Our food, even if it's animals, remember, even if we're eating a burger, say from a Culver's, well, what did the cow eat? Well, the cow ate the plants. The plants would not survive if we didn't have soil. So when people ask, well, why are we studying soil? Isn't it just dirt? Do we really need it? Do we really need to talk about it? Yes, it's very essential to life here on our planet. Here's a neat quote. Essentially, all life depends upon the soil. There can be no life without soil and no soil without life, and they have evolved together. Here's an interesting statistic I pulled off, and it's kind of startling. Since 1776, we know that's when we became a country. Since 1776, U.S. topsoil depth has decreased by 35%. So if you think about that, in a little over 200 years, we've lost about a third of our soil. What's going to happen if this rate continues? You know, another couple hundred years, are we going to be at 66%? How low can it get before we can't grow enough food to feed everybody? So, what is it and where does soil come from? Well, soil is made from rocks that break apart or wear away over many, many years. And this is referred to as weathering, the breaking down of rocks. Now, soil also contains things such as air, water, humus, and we're going to talk about humus in a little bit. They have the decayed remains of dead animals and plants. And here's an interesting statistic. It may take anywhere from 100 to 1,000 years for 1 centimeter of soil to form. So you look at that and it's like, wow, really? It's going to take that long for it to form? Now, you go to places like Iowa. Some soil scientists are estimating it may take up to 2,000 years to get an inch of soil. So this is just a centimeter, 100 to 1,000 years. So you can see that soil is almost to the point where it's a non-renewable resource. Remember, a renewable resource, typically by definition, you can replenish it easily within your lifetime. So if you chop down a tree, you could grow a tree in 20 years, depending on what type of tree it is. It's going to be fairly large again. Whereas soil, if it's going to take 2,000 years for an inch of soil to form in Iowa, that's to the point where it's a non-renewable resources. So when we look at soils, now again, this is a generic definition of soil, and a lot of scientists will have different definitions for it. You know, a farmer will say soil is anything that can support plant life. And soil is the portion of the regolith that can support rooted plant growth. So different people have different definitions. The one thing most people agree upon, at least soil scientists, is they don't want you to call it dirt. So just a tip there, if you're ever talking to soil scientists, you know, don't call soils dirt. So what is this humus? We talked about it in the last slide. Humus is a dark, moist soil composed of bits of dead, rotting insects, animals, leaves, roots, sticks, food. Humus adds nutrients to the soil which plants need to grow and they need to live. So humus is really, really good to have in the soil. It's what's going to provide a lot of the nutrients. So when we look at this diagram of soil breakdown, there's a lot of air in soil. That's why it's so important not to compact soils down. If you're constantly running, say if you're in a yard, say if you're a farmer and you have a nice yard and the grass is really green, but if you're constantly running the tractors over it, the combine, other things, that you're constantly putting pressure on that soil, you're constantly compacting it. Over time, your yard may not look that nice. It's hard for the grasses to grow. It's hard for things to grow in that soil if there's no room for any air. You also have a lot of water there, you've got organic material, and you've got regolith. And we'll talk about regolith coming up right here. Regolith is composed of rocks and mineral fragments produced by weathering. If this material is transported by wind, water, or ice, it's termed sediment. Soil is that portion of the regolith that actually supports life and includes organic material, water, and air. So we were talking about weathering rates. Let's talk about soil and weathering rates. Let's tie the two together. Because eventually when things get broken down, eventually they're going to form soil. So weathering rates control soil thickness. Bare rock surfaces may take thousands of years to develop even thin soils. So if we remember back to our last unit on what we were talking about in the last unit, can you remember? Remember when we were talking about volcanoes? What did you call those parts? We were looking at a slide of Hawaii, and some of the lava was running off into the ocean and was creating new land. Remember what we called that? We called it a lava, do you remember? We called it a lava delta. Just like a river will form a delta, a river of magma will form a delta as well. And eventually that lava delta will form new land, and as soon as it reaches the surface of the earth, and eventually over time it will break down and it will form new soil. Now soils, if you look at the Midwest, they can be anywhere from 2 to 3 feet thick in the temperate Midwest, where soil formations occur at a rate of about 1 inch per 250 years. Now you heard me talking about Iowa. This is not, you know, a guarantee. You're going to have 1 inch every 250 years. So there are some places in Iowa that I recently read about where some of the scientists are estimating it'll take up to 2,000 years to get an inch of soil. Now the thickest soils may approach 100 feet thick, and this typically you're going to find in your tropical regions where you have warm temperatures and you have plentiful rainfall. And unfortunately, soil erosion in much of the United States is greatly outpaced by soil formation. So the soil erosion is, it's not outpaced by soil formation. Soil erosion outpaces soil formation. So we're losing our soil here in the United States faster than we can replenish it. And again, a lot of times people will call the Midwest breadbasket of the world, where we produce a lot of food for all over the world. But if we lose our soil, well, we're going to lose a lot. So a lot of people consider soil one of our most precious resources. And when we talk about the environment, you hear things like global warming, global cooling, which is it, which is it not. We talk about how oil is going to be depleted. Well, what about soil? Because without soil, it's hard to grow enough food to feed everybody. Now, when we talk about soils, we're going to talk about the soil layers. Now, soils can be divided into a series of distinct horizontal layers, and they call these soil horizons. And collectively, all these horizons, all these layers, we call it a soil profile. And each horizon or each layer is designated by a letter. Now, originally when this was first thought about, there was a layer A, B, and C, and it was pretty simplified. And then one day someone talked about there being an O layer. And the O horizon, this is where you have your organic debris. That's why they call it the O horizon. This is your dead leaves, your other plants, and animal remains. So if you were looking at soil, it would be that very, very, very top part. It looks very dark, and this is where you're going to have a lot of your organic material, very nutrient rich. Then below that, you're going to have your A horizon. This is a lot of times called your topsoil. This is, again, going to be pretty dark. It's going to have a lot of organic material mixed with it as well. Now, to keep things simple, we're just going to go with the A horizon, B horizon, C horizon, and we're going to talk about the O horizon. There are a few other horizons out there. For example, sometimes people will talk about there being horizon called the E horizon, which is basically a light-colored leach layer that falls below the A horizon. And then below that, you get back into the B horizon. So you have your O, A, B, C. Sometimes right in this area you have another layer that sometimes people will call the E horizon. We're not going to talk about that and these set of notes. That would be more for another class, a more advanced class, but we're going to keep it simple so you don't have to know that for the test. So moving on, we talked about the O horizon, we talked about the A horizon. Now let's talk about the B. In the B horizons, there's very little organic material present. The accumulation of iron oxide sometimes will give soil a reddish color, forming a petal-fur soil. Accumulations of calcium carbonate may give the soil, well, it may look like it's a white layer, and that's going to create a pedicle soil. And then finally we have the C horizon. This is composed of either weathered bedrock or unconsolidated sediments. Now, below this C horizon, sometimes scientists will talk about some other layers. For example, they'll talk about an R horizon, meaning, that's your bedrock. And sometimes they'll talk about a K horizon. So we're not going to get into that. We're going to keep it simple. We're going to talk about the O horizon, A, B, and C. And those are the things you're going to have to know for the test. Now, soil scientists have identified thousands of types of soils. Remember, when we talk about a soil, what is a good soil? A good soil consists of about 40% sand, about 40% silt, and about 20% clay. And that's the perfect soil. And when we talk about classifications of soils, we can divide them into lots and lots of different classifications. But to make things easier for us, we're going to give them two basic classifications. We're going to talk about pedifel soils. We're going to talk about pedicle soils. And these are very simple designations that we're going to give to soils. The wetter soils are your pedifel soils, and the drier soils are your pedicle soils. So when we look at a map of the United States, and this blue right here is basically the outline of the Mississippi River. Now, is it exact? No, the Mississippi River is going to run over here, and it's going to run up between Wisconsin and Minnesota. But it's pretty close. But there is a line across the country, and this line, typically to the east, we have 30 inches of rain a year or more. And typically to the west, there's less rain. Now, is that everywhere? No. The Pacific Northwest, and there are some places that break the 30 inches of rain. But your pedifel soils are your soils where you're going to get that moisture climates. You're going to get more of the rains. And your pedicle soils you find them where you have your drier climates. So let's talk about Wisconsin. How many of you know what the state bird for Wisconsin is? If you said to Robin, you're right. How many of you know what the state tree is? Is it the sugar maple? Well, we actually have a state soil, and it's the Wisconsin state soil is actually the Anago series soil. So here we see a picture of the Anago area. So the Anago soils are among the most extensive soils in Wisconsin. They occur on about 300,000 acres in the northern part of the state. And these soils are very productive soils. They're good for corn, small grains, and hay. In some areas, potatoes or snap beans are actually an important crop. And the steeper areas are used for pasture or for timber production. So these soils are very productive. And even for things like potatoes, a lot of people probably think, well, potatoes, don't those come from Iowa? Well, Wisconsin has quite a few potatoes as well. And there's actually some companies such as Awesome Produce, which is a small produce company I worked for, a great company over by Friesland, Wisconsin, and they get a lot of their potatoes from this area. So in 1993, the state legislature actually designated the Antigo Series as the official state soil for Wisconsin. It was named after Antigo, Wisconsin, which is a city up, if we look up here, found in this area. Actually, it's right here. It's found in this area of Wisconsin where you find the Antigo Series.